Good morning, student. In last lecture, we have learned irrational and real numbers. In this lecture, we start our next one, decimal form of irrational numbers. Decimal form of irrational numbers. Find the square root of 2 and 3 using division method. Here we use division method to find square root of 2 and square root of 3. So here is an example. Find the square root and 3 using division method. Square root. Firstly, we find square root of 2. Here. Write 2. Here we take 3 similar numbers. That is, we write that number 3 times. One is here, 1, 1. And 1 here also. Then add this number. 1, 1, 2. Here 1, 1, 1. And we write here multiplication of these two numbers. 1 into 1, 1. Here we subtract 1 from 2. Then we get 1. Now here is number 2, which is less. Here is number 1, which is less than 2. So we take here after decimal 2 zeros. Mark. Make a group of 2 zeros and write 2 0 as it is. Here now, and take a point here also, because here we take point. So take point here. Decimal point. Now, if here we take number 4 3 times, 4 and 4 here also. If we take 5 here, if we take 5, then if here we take 5, then multiplication is greater than hundreds. So here we take 4 3 times and add 4 4s are 6, 1, 4 2s are 8 and 1 9. Remember that here we do addition, here subtraction, and multiplication of this both numbers right here. 24 into 4s are 90. 24 into 4, 96. So we write here 96. And if here we take number 5, the number will get, it is greater than 5. greater than 100. So we take number 4. Answer is a 96, which is less than 100. So we take 4, 4 and 4. Now, here we do addition. 4 plus 4, 8. And here we write 2. Now, after 8, we take a number here. So, do subtraction. That is 4. Take 2 0 again. Here also take 2 zeros. Now, if we take here 1, 1, 1, then multiplication is less than 400. If we here take 2, then multiplication will get is greater than 400. So we take 1, 1 and 1. 281 into 1, 281. So here we subtract and here we add. So 2, 8, 1 plus 1, 2. Here 1, 1, 9, 0, 0. Subtraction of that number is 119 and taking again 2 0. Here also taking subtraction is 119. Now here we take 2 zeros. For then here also we take 2 zeros. Now here we take number 2. 2. 4, 4. So here we are also number 4. We write number 4. Now we will do here addition. 4 4s are 8. So here we write 4 4s are 16. So here we write 4 4s are 16. 6, 9, 2, 1, 1. Here we do subtraction. And here we do addition. 8, 2, 8, 2. Here we get 604. In this way, we get square root of 2. Therefore, square root of 2 is 1.4142. So on. That is, note that in the above division, numbers up to decimal point are unending. It is non-terminating. Even no group of number or a single number is repeating in its quotient. Non-terminating. Even no group of numbers or single number is repeating in its quotient. So decimal expansion of such number is non-terminating, non-recurring. Non-terminating means not unending. And when it is called non-terminating, when non-recurring, when even now we find square root of 3. 3. Take 1, 1, 1, 3 times. Then multiplication 1 into 1, write 1 here. Subtraction is 2. Here addition is 2. Next, take a point here because there is a 2. So here also take point. Then 2 0 and right here 2 0. Now here is a 2. If we take here 7 7 7 3 times, and here addition multiplication of this integer is 189. 27 into 7 is 189. Here we do subtraction. Subtraction is 11. Here addition is 34. Next, take a group of 2 zeros. Here also take 2 zeros. And here take number 3, 3, 3, 3 times. If we take here number 4, the multiplication of 343 and 4 will be greater than number 1100. So if we take 300, if we take 343 into 3, then we get a number which is less than 1100. So here we take number 3 3 times. So here we do addition. 3 plus 3 6, 4 3. Multiplication of 343 into 3 is 1 0 2 9 minus 7. Answer is the 0071. Take a 2 0. Here also take 2 zeros. Here is the number 3 4 6 2 2 2 3 times. Here we write 6 9 2 4. Here subtraction is 0 1 7 6 and addition is 4 6 4 3. It's non-terminating. Here square root of root 3 also non-terminating and non-recurring. Root 2 and root 3 are irrational numbers. Hence, 1.414 and 1.732 are irrational number 2. Moreover, a number whose decimal expansion is non-terminating, non-recurring is irrational. A number whose decimal expansion is non-terminating, non-recurring is irrational. Non-terminating means not there. This quotient is unending and non-recurring is no group of numbers or single number is repeating. In its quotient is called non-recurring. So root 3 and root 2 is an irrational numbers because quotient of these two numbers are non-terminating and non-recurring. Number now we see introduction of number pi. Pi is a number. Pi is a number. Here, activity is given. Activity first. Draw 3 or 4 circles of different radii on a cardboard. Cut these circles Take a thread and measure the length of circumference and diameter of each circle. Note down the reading in the given table. If we draw a circle, then this is circumference of circle. Length of this is called a circumference. This is called a circumference and diameter. Here is a center. This is the diameter. Take a different radius and draw circle on cardboard. Cut this circle. Take a thread and measure the length of circumference and diameter of each circle. Note down the readings in given table. First radius 7 cm, then 8 cm, and 5 cm. Then its diameter is for circle first 7 to the 14. That is diameter is 14 cm. If radius is 8 cm, then diameter is 16 cm. If diameter is 5.5, then multiply by 2, then we get 11. So diameter is 11 cm. How to find circumference? Circumference is equal to 2 pi r. From table, the ratio C upon D is nearly 3.1, which is constant. This ratio is denoted by pi. This number is called pi. Complete this activity. And note down ratio, that is C upon D. Here circumference is given, then find diameter from circumference, then take a ratio of C and D. Verify ratio of circumference to the diameter of a circle, approximately 22 upon 7. The ratio of circumference to diameter is always nearly equal to 22 upon 7 is called number pi. It is activity second. To find the approximate value of pi, take the wire of length 11 cm, 22 cm and 33 cm each. Make a circle from the wire, measure the diameter and complete the following table. Now we see ratio of the circumference of the circle to its diameter is constant number, which is irrational. Ratio of circumference of a circle to its diameter, that is C upon D. C upon D. It is diameter is constant number, which is irrational, and this number is irrational. This constant number is represented by symbol pi. We use symbol pi. So the approximate value of pi is 22 upon 7. Value of pi is 22 upon 7 or 3.14 is equal to C upon D. Circumference of that circle upon diameter of that circle is always nearly equal to 22 upon 7 or 3.40. The great Indian mathematician Aryabhat in 499 CE has calculated the value of pi as 62,832 upon 20,000. 1000 is equal to 3.1460. We know that root 3 is an irrational number because its decimal expansion is non-terminating, non-recurring. Now let us see whether 2 plus root 3 is irrational or not. Let us assume that 2 plus root 3 is not an irrational number. Where we prove that 2 plus root 3 is irrational or not. Irrational number is always non-terminating and non-recurring. Let us assume that 2 plus root 3 is not an irrational number, is not an irrational number. If 2 plus root 3 is irrational, then let if 2 plus root 3 if 2 plus root 3 is rational, then we write this number in the form of rational number, that is 2 plus root 3 is equal to P upon Q. Therefore, value of root 3 is equal to P upon Q minus 2. In this equation, left side is an irrational number and right side is rational number, which is contradictory. This is irrational number and this is rational number, which is contradictory. Our assumption is contradictory. So that is, it is not valid. So similarly, so 2 plus root 3 is not a rational, but it is an irrational number. Therefore, 2 plus root 3 is an irrational number. Similarly, it can be proved that 2 root 3 is irrational. The sum of two irrational numbers can be rational or irrational. Let us verify it for different numbers. Hence, we prove here 2 plus root 3 is an irrational number using contradiction. That is 2 plus root 3 minus both are irrational number and sum of two irrational number is rational. Now 2 into root 3 into root, both are irrational and multiplication of these two irrational number is rational. Root 2 into root 5 is, which is irrational. 3 5 minus root 5, so subtraction of two irrational number is rational. 2 root 5 minus root 5 is equal to root 5, which is also irrational. Remember this properties of irrational numbers. Addition or subtraction of a rational number with irrational number is an irrational number. Multiplication or division of non-zero rational numbers with irrational number. Property second, multiplication or division of non-zero irrational number with irrational number is also an irrational number. Property number 3, addition, subtraction, multiplication and division of two irrational numbers can be either a rational or irrational number. Now we see properties of order relation on real numbers. Properties of order relation on real numbers. If A and B two real numbers, then only one of the relation holds good. First property is, if A and B are two real numbers, then only one of the relation holds good. That is, A is equal to B, or A is less than B, or A is greater than B. Here, if A and B are two real numbers, then only one of the relation holds good. That is, if one condition is A is either A is equal to B, or A is less than B, or A is greater than B. Now see next property. If A is less than B, and B is less than C, then A is less than C. If A is less than B, B is less than C. In this two numbers, A is smaller number. In this, A is smaller than B, B is smaller than C. Therefore, A is smaller than, obvious, A is smaller than C. This is property second. Now property third. If A is less than B, then A plus C is less than B plus C. Here we add same number C. A plus C, B plus C. Then value does not change. Property number 4. If A is a less than B and C is greater than 0, then AC is less than BC and if C is less than 0, then AC is greater than BC. Verify the above properties using rational and irrational numbers. Here, if A is less than B and C is greater than 0, then AC is less than BC. Here we multiply both sides by C. Then value is not changed. So the symbol is right here as it is. And if C is less than 0, then AC is greater than BC. Symbol will be changed. Here is the right greater sign. AC greater than BC. Now our next point is square root of negative numbers. These are the properties of order relation on real numbers. Now we see square root of negative numbers.